Hello girls, now we will work on problem 5.12.2. You can find this problem in the forces chapter, chapter 5. So, the problem says that Maria has a mass of 27 kilograms. She's a petite girl. Now she's hangs motionless on the monkey bars. So this is Maria, okay? And with both hands gripping a horizontal bar. So what's happening is that there's a horizontal bar on top and she is using both her hands to grip it. Assume her arms are vertical and evenly support the body. What is the force of tension on each arm? So they said that these arms evenly support their body. So that means that the force of tension in each arm is the same. Why? Because now her arms represent two ropes. There is a force of tension in them. They are pulling her body. Since they said that they evenly support it, it means that her body's forces, or the weight and any other forces, if we find any other forces, will be distributed over these two ropes or hands. Okay? So now we will draw Maria's body and try to find the forces acting on it. So what forces act on Maria's body? First, like every object, on the vertical we have the force of weight acting on it downwards. And we know that we're going to use the weight, so we might as well prepare it right away. We know that the weight is equal to the mass multiplied by the gravity. So it's 27 multiplied by 9.8. And the answer is, I will use my calculator. The answer is, according to my calculator, 264.6. Of course, I know that I need to use only 3 significant figures, so I'm going to use 265 newtons. It's negative. Now, I'll take a look again at my figure. What forces are acting on Maria other than her weight? There is the tension force on the first arm and the tension force on the second arm. Anything else? There's no normal force because she's not resting on a surface. So that will be it. I can see that she is motionless, which means that velocity is 0 and she is, according to Newton's first law, I can say that F net is equal to 0. So, F net is equal to 0. I will substitute. What are the forces acting on her? There's T1 and T2 and W. That is all equal to 0. T1 is a variable. I want to find it, so I'll just leave it. T2 is another variable, but I know that they are equal because they said they are evenly supporting her body. So I can substitute T1 instead of T2 again, because T1 is equal to T2, just to eliminate one variable. Plus the weight. I know the weight. It is negative 265. All that is equal to 0. So 2T1 minus 265 equals to 0. So 2T1 is equal to positive 265, and from that I can say that T1 is equal to, I will quickly use my calculator, It's 132.5. Well, I know that I need to use only 3 significant figures. That's why my answer is 133 newtons. And that is the same for T2 also. So, I take a look. Both of these forces are positive, makes sense because they're pointing upwards. I used 3 significant figures, makes sense, and this will be my final answer.